Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to wrap up our discussion in this module by talking about matrix multiplication. And I want to spend a lot, or I shouldn't say a lot, but I want to spend a fair amount of time going through matrix multiplication, both conceptually and also with a number of examples. Because matrix multiplication is the first time in matrix algebra so far that we're going to encounter something that doesn't work the way that we expect it to. Right? Once we got our heads wrapped around the terminology, right? Addition and matrix subtraction and scalar multiplication all worked pretty much exactly as you'd expect them to. Matrix multiplication is really the first case where things work differently. Now, I'm not saying that they're hard, I'm just saying that they work differently. And really having a good understanding of why things work the way they do will help you out in the long run in terms of being able to catch the mistakes that you make as you go through the process. So, before we get into actually multiplying anything, I want to go back to this idea of dimensions for a second. Right? So, let's take two matrices. I'm not going to give them any values or elements. I just want to say we have two matrices. Matrix A, which we're going to say is going to be a 3 by 2 matrix, and matrix B, which we're going to say is a 2 by 4 matrix, right? 2 rows, 4 columns. So again, we're not going to do any actual multiplication, but what would the dimensions be of AB? Right? What are the dimensions? Right? And the reason I want to start with this is because this is the sort of fundamental idea behind matrix multiplication, and you can save yourself a lot of time if you realize some very basic principles of matrix multiplication. And so that has to do with the idea of inner dimensions versus outer dimensions, okay? So if we take A times B, right, these two here and this two here, right, these are called the inner dimensions of the multiplication, right, because they're on the inside, right? You can think of this almost like FOIL, right, first, outer, inner, last, right? This is kind of set up like a FOIL, where these two here are the inner dimensions of the resulting matrix. Conversely, right, this 3 and this 4, right, these are the outer dimensions. I don't want to get too sloppy, so I'm just going to put dims. Right, these are the outer dimensions. Okay? And so we can basically make a statement here that if the inner dimensions match, which in this case they do, right, a 2 and a 2, then the resulting matrix, right, the result of their multiplication is going to have the outer dimensions. Right, it's going to be a 3 by 4, okay? And we're going to see what that looks like in some conceptual examples and some real examples in a minute. But I want to drive home this idea that if the inner dimensions match, then the resulting multiplication is going to have the dimensions of the outer dimensions, right? 3, 4, okay? So let's ask ourselves, scroll down just a little bit here. And let's say, well, what about, right, A, B, same dimensions. Well, what about BA, right? What dimensions? What dimensions does BA have? Well, actually, hold on. just going to really quickly delete this because I want to flip them around. Okay. So what if instead we were to multiply b times a? We're going to keep their dimensions as 3, 2, and 2, 4, right? We haven't changed anything. We've just reordered them. So instead of multiplying a by b, we're multiplying b by a. Okay? So this is the first time where we really see the multiplication break down. Because if you think about this case, right, if we ignore, I just covered up the screen, you can't see it, right? If we ignore this whole thing over here, right, we're taught with numbers that multiplication is called commutative, which means it doesn't matter if you do AB or BA. That is not true. I repeat, that is not true with matrices. So let's look at what would happen. B times A. Okay? So the inner dimensions here now, right, are 4 and 3, and the outer dimensions are 2 and 2, right? Outer dims, inner dims. So what are the dimensions of BA? Well, here's the rub, right? They're not. Right? This is undefined. Right? This is undefined. You can't do this, right? This does not work. And the reason that it does not work is because these inner dimensions do not match. Right? Up here they did. The inner dimensions were the 2 columns from A and the 2 rows from B. They matched just fine. Here, right, the inner dims are the 4 rows or 4 columns from B and the 3 rows from A. They don't match. And because the inner dimensions don't match, we actually cannot multiply. Okay? I want to make sure I get that point across. The inner dimensions have to match, then the resulting matrix has the dimensions of the outer dimensions. Okay? If the inner dimensions don't match, we can't do the multiplication. I know this was a long-winded video and we haven't actually done multiplication yet, but I want to make sure you understand this concept of inner dimensions, outer dimensions, and what they mean for multiplication, and why they mean that you can do AB in this case, but you can't do BA in this case. Okay? So please rewatch this video if you have to until you understand this concept of inner dimensions, the fact that they have to match, and what that means for the dimensions of the result. Okay? If you have any questions, please reach out. Thank you.